Hi, everyone. This is Ron Badum from Atlanta Functional Programming. I guess we're just going to go ahead and get started here since it's now 5:30. I don't want to, this is a pretty detailed chapter that we're going to go through. Today, we're going to go through Common Lisp file I/O library and how Common Lisp actually handles files in most implementations. We're going to talk about very basics about how files are handled, some of the low-level routines to read-write files, along with sort of, I would say, a specialty in Common Lisp, for better or for worse, the path name object and its corresponding API. Those who actually are aware of this know why I am being a little hesitant with the path name objects, because it's a very complex topic, and I hope it will actually drive some really awesome discussion. Some announcements as we're nearing again. I'm going to mention this again at the end of this broadcast. There are a couple of Lisp-related events coming up. The Lisp Game Jam is in the month of April. More specifics will be posted at the end, both on the Atlanta Functional Programming Meetup page, as well as I will show the website here at the end of this broadcast. So let's just keep the ball rolling and get started here. So working with files in Common Lisp is going to be fairly basic, like working with files in any other operating system. Programming language that you're familiar with. You have the ability to open and close files, write inputs into files. It has a very low-level API that allows you to write complete strings, format strings, and so forth. It's actually split into, I would say, that the file I/O API and then the format API, which can take the same stream objects that you create from the low-level file I/O API. To create or at least open up a file, you can create a stream object by using something called the open command. Open is the low-level command to really open up file handles in Common Lisp, and it takes, as you can see by this function signature, several things. One is a file name. The file name can be a string. Later on, we'll discuss, when we discuss the path name API, I'll show you how this can also be done using path names, because anywhere that you could take a string, which in the file parlance, strings that are representing paths are actually called name strings. We'll discuss that a little bit later, but I thought I'd mention it here. So when I say strings, I really do mean name strings with respect to files and their paths. Additionally, the open command, as you can see, can take a direction keyword argument, which, if it's input, obviously that means you're reading in line by line. If you set it to output, you can actually go ahead and write to the file too as well. You have element types. By default, as you can see in the function signature, files are actually opened up as base character streams. Whether if you do input, obviously it's a character input stream, and if you do output, it's a character output stream. You have two additional things here, the keywords if exists and if does not exist. If it exists is checking literally with the file system, checking if the file exists, and if it does, you could do a couple things here. Supersede basically means you are I think it was like truncating and overwriting with the file. Appending is you're appending to the end of the file. You have the overwrite command, which I think the chapter actually goes through and mentions it as being returning a stream that overwrites existing data from the beginning of the file. So you see supersede and overwrite kind of look like they're the same thing. I honestly have never used overwrite. I almost always use supersede. I don't know if there's a specific difference in terms of how one versus the other would work. depending upon Lisp implementations. So if you're almost just replacing the current existing file, I would suggest using supersede. I don't know what other people might suggest on that. Besides those options, there's a couple of options here. Honestly, when I was reading this chapter and then going through the API, I was surprised that was there, but I don't know if the standard has them. And if you read the hyperspec, they're there. But I don't know if people use them and if implementations even have them implemented. So I want some of the experience.
The difference between overwrite and supersede. Overwrite will not change the length of the file, so you can basically only write the beginning. It'll put the pointer back at the beginning, but it's not going to truncate the file. Supersede is just going to erase the file and start it all over again.
Oh, so overwrite doesn't actually do a truncation at all. It just starts going back.
It just starts writing from the beginning again. All the old data is still there if you don't finish writing the whole stream.
Which means then overwrite literally does overwrite. So you could have like data corruption there if you're overwriting from the beginning of the stream and you didn't write the stuff. Yeah.
Usually you don't want to use that.
Yeah, you don't want to do that. I don't know in what case you would ever want to do that. That's but I'm curious because rename and delete, rename and new version. Rename, I think I've seen people use the rename files, but I never seen anybody use new version. And when I looked at this was brand new to me because when I was going through this, and I was like, "What is new version?" And according to the hyperspec, it literally says, "Oh, if the file exists, I'm going to attach some sort of version number to."
This sort of goes with the old the history of the path name system.
Okay.
Because path names are implemented with a file system that used to have file versions at the file system level. I don't know too much about it. I know Elijah knows a lot more about it. He'll probably be on soon. He's probably driving home right now, but he can explain it better than I can.
Okay, so I know that there is a history behind some of these keywords, and if they're whether or not they're available, I would say would have to be like based on like the file system that you're leveraging, and whether or not the Lisp implementation exposes that. That's the more important question. But I'm bringing it up because it is available in the hyperspec when you see it, and if you actually read through it, its use case makes sense, but if it's implemented, that's a question of it really is the question of the implementation that you're using, not the actual language itself. But again, when we get to path names, we can, really discuss this because that's where it's a lot of these newer, keyword arguments will sort of come into play. Additionally, if does not exist, just to finish our keyword arguments here, it allows you to either create the file by default if it doesn't exist, or you can also throw up an error saying file isn't available. And this error, I don't think you could specify an actual error string for yourself. I think the Common Lisp implementation actually goes ahead and generates that. So here, if we go ahead and just show up here. Let me just increase my Emacs buffer here. Just to give you an example of this guy right here. Obviously, I'm going to create a resource leak here for those of you who are going to be very pedantic about it. But it's not to worry. I'm not going to actually leverage this guy for the time being. But when you open up, you can just see that it creates a file system object here. It creates a character output stream. You have the ability to with the Open API to open up binary output streams. That it will be if you leverage something called if you set the element type to unsigned byte 8. This will become a binary file, and then you can use read byte and write byte, in which we will discuss later on as we go along. This is basic reading and writing a file here. There's nothing new here. We've actually touched some of this, in earlier chapters when we were discussing this in other study groups. But to reiterate, to read a simple line by line of a file, you have this function called readLine that you can see here. And in this simple example, I'm opening up a file and just reading in a line and printing it out. So if we actually go in and actually run this guy, you'll see that it opened up the same file. And it actually, and I'm going to just split the buffer here so that you guys can see this. Wrong split. And it actually read this file and read the first line of the file and then closed it. So there are many other ways of reading files, obviously. You can also, for example, this is just a way of opening up a file and just, checking if it doesn't exist. Right now, I'm not doing anything. If you do it, if you throw up an error, you can actually, say error and say S3, which I know doesn't exist. So when you try to run this guy, you'll see that it will say no such file or directory. And that's straight off. The error that you actually get, I think, is Common Lisp implementation specific, but most often you'll probably be based on the host operating system, whether or not you'll get that standard error message of no such file or directory or a Lisp specific message. There are many different reading functions in Common Lisp. I just went ahead and dumped out a couple of them here. Read line is obviously reading an entire string, including the new line character. Read character is a single character. Read byte, when you're reading binary data, will read a single byte. You have also read, which will read in an entire S expression. This is actually what's often used when you're doing the R in the REPL and the read about print loop. You have other things like also read from string, which will read in an S expression from an actual string, which I will show you later on, and read preserving white space, which I often use when I implement, some dumb interpreters that will read in S expressions. So people can actually constantly hit enter while they're typing in their S expressions. I'm sure a lot of this is kind of, straightforward. I mean, there isn't much anything new here. I will say that in the cases of where you're going to not do anything with files, like if they don't exist or whatever, often this is the pattern that I tend to use when I do use open by default, and that is I check to see if the stream is actually open, and then I'll go ahead and read or write to it and close it. Later on, when we talk about some limitations of this approach, I'll talk to you about with open file, which actually just goes ahead and wraps this pattern of let in and close.
Yeah, you probably never want to use open and close explicitly like this, because what happens if your format line did something where it failed?
Right, right, absolutely. I understand that. That's actually one of the reasons why I have some reasons later on that brings it up. You're absolutely right. There are reasons why you do not want to use this.
In my 10 years, I've never used them.
Right. That's absolutely correct. You almost always, I always forget open and close because I almost always go to by default with open file just to wrap it around it. So, but just to give you this at least introduction, with open file literally takes, I think, almost the same signature as open does. Yeah, it takes almost the exact same signature as open does, except it wraps this guy around this, essentially this let statement. It generates this code almost exactly with some optimizations. So this is a simple example of using read that I thought I would show you, that I thought was pretty cool. If you looked at the example that was shown in the book, I went ahead and copied this guy. One second. Boom. Page 14 of Lisp. Okay. Show you. Hold on 1 second. There we go. So we have here, just a bunch of expressions, whether they're lists like 1, 2, 3. You have atoms like 4, 5, 6 in a string, and then you have a list of lists like here in A, B, C, D. When we reopen this the first time, it'll, we can just go ahead and, slurp it into get the stream our object into a variable, and then we can just read these one at a time. So here we can read this line by line. You'll see the REPL will go ahead and read in these as if they're S expressions and return them as proper S expressions too as well. Additionally, it'll also, if we read this all the way through and then we try to read the end of the file, it'll also go ahead and spit out that we hit the end of the file too as well. Like Michael said earlier, you don't want to really use this, but when you do, always close your files. Otherwise, you do have a resource leak there. So, I almost never encourage you to really use those low-level libraries unless you really have to. Another example that I wanted to show also is read from string, which is often, I haven't seen this in the book, but I thought it was pretty cool to at least mention here. Because, a lot of folks tend to write, if you're writing a Lisp interpreter and in Lisp, I almost always end up using something like either read from string or read preserving whitespace, because there's convenient, APIs that will efficiently, generate a proper S expression for you. So you don't have to handle certain edge cases if you just use normal read, for example. So in this here, I've generated a simple expression that's a string of a list expression, and you'll see that this will properly read in, evaluate it, and print out 1 + 2 + 3. Nothing real special there, but it's some pretty cool stuff that will allow you to quickly write up interpreters, especially if you're writing interpreters that leverage S expressions. To write data to a file, there are a bunch of, just like reads, there are a bunch of writes. You have write char, write line, write string, write byte, and so forth. But then on top of that, you have several different things related to writing new lines. One is called terpre, which is short for terminate print. It will always flush out a new line for you. Then you have something called fresh line, which checks to see where the position of the character is. That means if the previous character is already a new line. So if it's already a new line before, it will assume that you're at the beginning of the line, and then it won't generate a new line for you. And to illustrate this, what I did was I created a quick dumb example here that writes out hello, and then immediately puts in a new line, then tries to call fresh line, and writes out the iteration that it's in and closes the file. So just to show this, if we go ahead and run this guy, it ran the loop about 5 times. And if we open up this guy, you will see what happens is it never actually put in 2 new lines, even though we explicitly said to put 2 new lines. And that is because fresh line, what it did is it checked and noticed that we're not in a new line yet, and it skipped itself because there was nothing written on that current line. So this allows you to format your tables and create some nice serialized character output and prevent spurious blank lines from showing up because you're constantly calling terpre when you don't need to. I thought that was pretty nice, and that is if you're using write line. I almost always honestly use format, and you will learn more about format and what's available in format later on in the book. But for now, the basic format stuff that you saw earlier, if you're using that and use something like format, I'm just going to write this to standard out, and you do tilde-a, which takes in some sort of Lisp form, and tilde %, which is essentially a new line, and then write 6. It will go ahead and format everything correctly. It's essentially printf for Common Lisp format is, which
I believe it's tilde ampersand is the fresh line.
Tilde ampersand?
Yes.
Okay.
You could do tilde ampersand tilde a tilde percent. Just add the tilde ampersand at the beginning, and it will never add that new line because you already made the new line at the end.
You said tilde a, tilde ampersand, tilde percent, like this?
No, tilde ampersand before the A.
Oh, gotcha.
That would be like, it's not going to add that tilde ampersand new line because it's only going to add it for the first iteration.
Gotcha.
Because
It
we
won't
already
show
made one.
here. It will show if I end up doing like a do time. So. Times format T tilde ampersand tilde percent. It didn't show up. Okay, that makes sense. Actually,
well, basically, that's all you need to know is they're the same as the terpre and the fresh line.
Right. Let's see if that works. Well, that's because I put two at the end there. All right. So, let's talk about functions that output Lisp as as expressions, because there's a bunch of them in Common Lisp. I've actually shown one that I almost always end up using, which is print. Print just takes the S expression, evaluates it, and then prints it out by a new line and adds an extra space. But there's also print1, which just prints it, doesn't put in a new line at the end. And you got the pretty printer. And the pretty printer, I couldn't think of a good example that allows me to actually do a p print. I tried earlier, but I couldn't get a fairly decent example that does p print that will allow me to leverage p print. But pretty printing basically gives you a nice way of at least humanly read some of the S expressions as you read them into the Lisp interpreter and store them in memory. If you want to print about how human readable your S expressions is, you have this print readably flag. Obviously, what I showed you earlier about, like I said, about the let open close problem, and as Michael alluded to, there's a couple of things that you have to worry about related to doing that. Primarily that, it's error prone. If you forget to close the file, just forgetting to close the file, ignore, what we were talking about, just even returning from a form. If you forget to close a file, you got a resource leak. I mean, that's just guaranteed. You have the additional thing is, even if you did include close, well, what if you have return and return from in your code block? Well, you have multiple places where you have to remember where, you have to add close. So that makes your code a lot more fragile. And again, makes it potentially prone to resource leaks. And again, if you jump out preemptively due to an error of some other function that you called or whatever, that also could potentially cause a resource leak and not close your file. So bottom line, for 90 to 90, I would say almost 99%, there are very few cases where I can think of where you would actually use open close, just almost always use open file with open file. And this is an example just to show that with open file takes almost everything as we did before. I just took the previous example and just rewrote it with open file. The only difference here is this list used to be in like a let with an additional pair of parentheses, but now it's just one. That might be the only thing that looks even strangely different, but everything else is pretty much the same. Any questions so far? Cool. All right. File names. Now, I really want some to at least discuss this, because there's a historical anecdote about why file names were written the way they are in Common Lisp. And in fact, Peter in his book went through it a little bit. At the time, file names as strings was hugely dependent upon the operating system file systems that you were leveraging. At that time, there were almost thousands of different operating systems. They only mentioned a couple there, which is like 10x, TOPS 10, TOPS 20, Unix, Multics, MIT, of which there were several standards, MIT Multics being one of them. And each of them have different ways of presenting files. So what Common Lisp did when the Common Lisp standard came out, it said, okay, you know what? Instead of using strings, I'm going to create an object called a path name and make this a quote unquote portable way of representing file lists inside Common Lisp implementations. And there's a little joke that ends up going on about it, because there are a lot of quirks about this, mainly because of operating systems have evolved since and we sort of converged on file system and files representations, and you'll see some of the consequences of this later on as we go through path names. But one thing to note is that almost all places where you want to use a path name or even a file name, both path names and name strings, which are basically strings that represent a file path, are accepted by the API. Some rules that were suggested in Practical Common Lisp that I think we should discuss is if when you're writing applications, especially if you're getting a path by an end user, just go ahead and use a string. Go ahead and use a name string. It will almost be it'd be best, and it's far more usable and far more portable than trying to construct the path name object. But if you're programmatically generating it, using path name objects is it'll be probably your best bet to essentially create. But I know that there's a comment coming up. So, Wilfredo, why don't you tell us if this is a good suggestion or not?
So, I mean, there you're getting into application design, but I mean, it's hard to handle. Paths are a hard problem, just in any context whatsoever. That said, I think I generally disagree with what you said about just using the string that the user gave you, because the problem with that is that name strings aren't just dependent on the operating system; they're dependent on the Lisp. So when you ask the user to give you a string and you just toss it into Lisp, you're basically expecting the user to know how that string is going to be interpreted by the Lisp, specifically on that operating system. So I like it, but that's more of an application design level. What I think is more, if you ask the user for a directory, and you're expecting a directory, try and coerce it into that. Or if you're expecting a file, try and, but that's really kind of like outside of the scope of Lisp itself. That's more of how you design your application.
True.
But I generally would never pass strings raw to any of the Lisp functions that I got from a user, because again, that doesn't seem right. Because it goes through multiple levels of interpretation that there's no way you can't basically like come up with examples of usage of your program and reliably say, this is what my program will do given these strings, unless you make it do those things. And you account for all the different implementations and of lists and operating systems.
Right. So I think what Peter was suggesting is not necessarily to leverage name strings completely, but to at least take the name string and then convert it to using a make path name. Like you could take at least that's how I understood it when I originally read this. Obviously, in a lot of cases, I'm almost always end up programmatically generating it because I'm writing the code anyway. So it doesn't make any sense at that point if I'm writing.
So I'm a fan of consistent behavior, and I'm an extreme fan of consistent behavior when it comes to files and the file system. So I feel extremely unease just giving a string into make or parse name string or any of the Lisp functions without me like inspecting a little bit first.
Right. That's a very good, very valid point. And later on, and because again, what I was talking about convergence of operating systems and file representation, right? You know, and you alluded this to it earlier, and I'll just go ahead and bring it up. Because of Unix and Windows sort of deciding, okay, you know what, doesn't matter. Directories and files are going to be the same thing. There are now essentially two different representations. Well, just to show one of the quirks of the path name API, there are two different representations of paths, which is, you know, the directory form where, you know, you decide. I have an example of this. You decide to go ahead and, you know, put everything in the directory comment of the path name object, and then you have the file form where you actually populate the name part of this. And both of these are actually valid in Unix and in Windows, because it'll go ahead and, you know, look it up accordingly, because, you know, it'll treat it as a file. But in other earlier operating systems, that actually, if the name was not populated in the path name object, it will cause an error. I try to, you know, err on the side of caution when dealing with, you know, make path name, and that is, you know, fill up as much of the path name object as possible. Sometimes I do it a lot by hand, which is kind of like what I was showing here in this example here, which is make path name, taking a relative path, and then creating the actual, you know, path at the end of the file, specifying the name, the type, and the directory. But, you know, I've also seen other people, and this is what's suggested by Practical Common Lisp, which is, you know, go ahead and use defaults. You know, have some sort of test path, you know, set up, and go ahead and you know, use that to determine, you know, what the base part of your path name object is going to be, and then leverage that to create your file name. So there, you know, a lot of different, you know, quirks about leveraging the path name API. But I do agree with you in general, at least when it comes to name strings, don't put complete faith into the name string. Try to pass it into and create a path name object, and let the API sort of like tell you whether or not it's a valid path or not.
As a note, hello everyone, by the way, I finally am vocal. Based on the wording of the hyperspec, first, I don't know if you can rely on this either, but based on the wording of the hyperspec, if you pass a string to open, the implementation is at least perfectly allowed to proceed to parse that out into a path name and then unparse it back into in whatever underlying string representation the operating system uses. Because open is marked as taking a quote-unquote path name designator.
Yeah, right.
A path name specifically, not, you know, some actual path in the underlying system, right? And so taking a path from the user and then passing that directly to open, you don't actually know that that path is going to go directly down to the OS. There's a possibility that the implementation will parse that and then unparse it again, to use the terminology SBCL uses. And so if there's some weirdness in how SBCL does parsing, it's entirely possible that, you know, what the user is expecting, you know, to happen will not happen at all. Because SBCL parses the name string slightly differently than the actual operating system would.
Right. And to add more, you know, confusion is the entire device and host thing, at least for people who are using Windows, because some implementation populate host and other implementations populate device for where the drive is being, you know, inserted into the path name. So it's it's a very sticky mess, you know, just in general when you're dealing with it. But at least it's better now that things are, you know, sort of unified at the file system level. So you can use a subset of these designated, of these keywords when you're creating your actual path name objects. And I would at least think for most cases you'll be good, and it'll be a portable implementation. But I could be wrong on that.
You're generally okay as long as you're not trying to. As long as you're not actually trying to do anything that involves relative paths,
Okay.
automatically that's very difficult. Like it's far more difficult than it should be. But if you're doing stuff, you're trying to list a directory, you're trying to go through some files, stuff like that is generally okay. But if you're trying to, like go up a directory or that sort of thing, there you kind of run into trouble. I mean, as an example, what you have right there, where you have directory and you have a relative specifier, that's not called out in the spec. That I know that works in SBCL. I know it works in Clojure Common Lisp, but I don't know that it works, where else it works. Stuff like that. But yeah, generally you're right. Generally you're okay. Generally you're fine unless you're trying to do more file-based sort of thing.
Would you say though, because you mentioned relative paths, that it would probably be more reliable to leverage absolute paths in most cases than relative, and try to avoid relative in general? Well,
what I mean about relative is, for example, I have this is, I think, a pretty common scenario. I've got I'm given a path name, and I want to I want to list files that are in the same directory as that path name, something like that. Or I want to go up a directory, from that path name. Stuff like that, that sounds like it's simple, has so many little gotchas involved in it. So that's what I mean by relative, is when you're trying, specifically the operations of trying to go up a directory or trying to get a relative, say you're trying to construct a relative path name from an absolute one, and you're like, okay, I'll just use enough name string or enough path name. It's like, well, yeah, those don't exactly work how you expect them to.
Interesting.
Yeah, just a lot of little gotchas that make whenever you're trying to construct path names out of other path names. If you're going forwards, if you're going down the directory structure, you're generally okay. But if you're going up, good luck.
So what are your thoughts? And because I was going to mention this here, with third-party libraries and that sort of leverage some of the portable path name stuff. Peter wrote a bunch of helper functions that I think Edie White's actually created a wrapper library for, called CLFAD.
Yeah, and that was usurped by UIOP.
Okay.
So there's a lot of functions there that are utilities. However, a lot of those things are still that doesn't really invalidate anything that I said. All those things are really hard, even when taking into account UIOP. Okay. It does not add a lot of things that I would consider necessary for doing actual file work.
Gotcha.
As a note, relative paths are actually listed in the spec.
Yes, I saw that.
No, yeah, but the relative. So in the directory component, the relative keyword.
No, that's listed.
That's in the spec.
Oh, is it?
Yes, relative
yes.
is.
Yeah.
Oh, I'm sorry. I knew that absolute was
19.2.2.4.3. I'm looking at it right now.
Thank you, Elijah.
Sorry, I couldn't help it.
I'm sorry. Yeah, I know absolute. I know wild. I know unspecific. I wasn't 100% on relative.
Home is definitely not listed.
Oh yeah, yes, you're right.
SBCL has home. XBCL actually even has user-specific home, which I've always found kind of cool. But that is completely not suitable.
And you'll see stuff like back and up as well
Yeah.
that are used by SBCL, and CCL I think uses back. SBCL I think
back and up are actually also both in the spec, but exactly what they do is left a little vague.
Got it.
Like, they're listed as go upward semantically and go upward syntactically.
Right.
Which you can interpret it in a number of ways. Like that, I can make a very good argument for what that should do on a Unix system, but yeah.
And I'll go back to what I said initially. Paths are hard. It is genuinely a hard problem, and unfortunately, so I think that the best way to handle paths is to have like a good library that everyone uses, and then at least you get consistent behavior. That way, and it's like, well, if it does the wrong thing, at least they're all wrong, as opposed to some of them being right, some of them being wrong. And that's where, unfortunately.
What would you recommend folks to use to at least have consistent behavior? I guess it's the question.
UIOP is pretty much the best you can do. There's a couple other utilities floating out there, but the problem is I don't think they're like either they're not consistent or they go against, they re-implement some stuff from UIOP, but don't do it the same way, and then it's like you're running into the same sort of thing. So honestly, I hate to be bleak about it, but but fact of the matter is, like, I don't think that there's like any like solid path name utilities where you can just get started and you can, I can go up a directory, build a relative path name, stuff like that.
So folks who are watching, who are just tuning in, UIOP is the recommended library for dealing with path names.
Yeah.
And you don't even need to install it because you already have it. If you're using QuickList.
Yeah.
So folks,
but even there, it has you should be aware of a couple little surprising things because of the fact that it's path names. I think I brought up a couple weeks ago stuff like path name, directory path name behaves. If you look at path names, it makes perfect sense, but it doesn't make any sense whatsoever when you're thinking of like file names in the modern sense. The behavior can be surprising.
Interesting.
But UIOP generally behaves how Lisp path names should behave, which unfortunately is sometimes surprising to how file names usually behave.
Interesting.
Yeah, path name, directory path name, and path name parent directory path name, I think are the
yeah.
Which, as you said, make a lot of sense if you understand how path name objects is structured, but make very little sense compared to how we're used to operating on files and tabs in modern OSs.
Right.
It's kind of silly.
Again, I'm gonna defend the spec a little bit because at the time it was a historical consequence. By the time they standardized, they didn't expect everyone to go down this path, and I guess whoever went through the standardization efforts are like we have a broken path name implementation. We'll just deal with it on an implementation by implementation basis rather than go through the exercise yet again. They just decided.
I do have one other thing, right, which is that if you're developing a particular application and you're the one who's going to be distributing that application, meaning you actually know what implementation you're using, individual implementations, although they may disagree on what the right thing to do is, generally do have pretty sane behavior in and of themselves.
Mm-hmm.
And so if you're willing to restrict yourself to a particular implementation, you can choose to learn that, and then you can use their path name API in a reasonably sane way. That is always an option.
And that's what I meant, where it's an application concern more than anything else. Just like, because you can definitely make it work for your application, but for general use, again, you're perfectly fine, unless you're if you're actually trying to build up a good application, you're going to have to delve into a little bit more. And you're doing file-heavy operations. Like, you can definitely build a lot of applications that don't run into that many problems. That you can use UIOP and the standard functions and be fine.
Interesting. Are there common like convenient functions in UIOP that like for listing files and directories and
Yeah.
So I'm just trying to find like some documentation that I could just quickly show some folks, because I think it would be useful just to.
Oh, welcome to the world of Lisp.
Yeah. For UIOP, 9 times out of 10, unfortunately, I end up pressing meta period to go to the source. Because some of the documentation on that's a little.
Yeah, there are some nice functions though for listing directories. It almost completely overlaps CLFAD. You can recursively list them, run a function on each file it finds, etc., etc.
Okay.
Yeah, and honestly, sometimes what I have done in the past is I'll actually look up, like I'll go to the CLFAD page, just kind of get an idea, and then I'll look up the corresponding function in UIOP, because usually they're named very similarly. So, and that's just because CLFAD has like an actual documentation page.
Actually, I think there is a documentation page on QuickDocs for. Nope, it's not complete. All right,
Yeah.
Is that question? Geez. All right.
I'm sure there's UIOP documentation somewhere, but I just generally just look at the source combined with CLFAD, and
just go.
Like I said, we're kind of in an unfortunate spot, and I wanted to say, like, I don't disagree with you whatsoever in defending the path names spec, like whatsoever.
Mm-hmm.
What I think what I think is that we need a library that is willing to compromise the sheer flexibility of path names for a little bit more usability.
I actually would agree in a lot of respects to that, because of the fact that I feel that given the history of the spec, and now that we understand how file systems are being designed nowadays, almost all of them have sort of like unanimously agreed how directories and files should sort of work.
Mm-hmm.
And literally that just means they're all files. We should revisit, and re-implement a proper, Lisp library that leverages that and, make it much more cleaner. But that's on the, obviously that's a very large undertaking. Hell, even UIOP, just to, because ASDF uses it, right? I mean, it has its own quirks. Not creating that is sort of a sign that it's a far more difficult problem. Otherwise, I would have totally seen them, because they were designing to create this, build system type thing for Common Lisp and ASDF. They would have at least tried to attempt to solve that. The fact that they couldn't, or they didn't, shows that it's much larger than where we're probably just estimating right now.
Yeah.
Go
ahead.
One concern is that convenience in another respect, which is that the standard library functions that actually consume the path names, wouldn't accept whatever new path name object structure you define, unless and if we use strings as our format, then you're running into the same little problem I mentioned before of whatever string you generate, it's perfectly valid for the implementation to go and reparse and reconstruct that. So
yeah,
the
library, the library that I'm picturing would kind of take the half of the UIOP approach of you generate path names, but you generate them in such a way that they produce expected behavior on each given implementation and platform. That would be the implementation of the library. So if you know that to go up a directory on SVCL, you put an up, that's how you do it if you're on SVCL. So a library that does all those sorts of things. So basically, it's UIOP. I just think that UIOP is missing a lot of critical functions Not even a lot, just a couple of critical functions. And another thing too is when you're building such a library, you kind of have to decide, which is where I disagree with UIOp, is do you want to produce behavior that makes sense given path names, or do you want to produce behavior that makes sense given like modern file names? You know, and I go back to path name directory, path name, or path name, like path name directory. Like what that does and what I expect it to do are completely different things, and it's based entirely off of file names versus path names.
Man, that's a so that's a very. I mean, this is a very interesting and very important discussion because, as you said, it has very large effects on application design, and it has more and more people. Has more people, you know, has those folks who are actually watching this, and you know, as you're getting into Lisp more, this is something that you can you need to consider as you're designing your application how to handle path names. There is a nice portable way of doing it. There are some nice libraries like UIOp that handle it for the most part for you in terms of portability, but there are some little quirks that you need to be aware of as you are working through and writing your applications. The end of this, and there are a lot of other functions that I really am not going to go through here. One last thing I think most people would end up wanting to know is probe file, which will take a path name and tell you whether or not the file exists. Now, in this example here, I'm using clearly a non-standard extension here with $home. I mean $home, but it takes in a path. Right now, I'm making the path through make path name and checking with through probe file to see if the file actually exists. If you actually run this guy, you'll see it'll output if the file exists, the path name that was to which it mapped to. But if it doesn't exist, it will go ahead and return nil. So you can use that as your check to see if you can read or write to the file. There's also functions like ensure directories exist. But again, a lot of these are available in the standard, but really you may want to take a look at UIOp and other third-party libraries, which handles a lot more of the intricacies of handling files with the different operating systems for you that the low-level file API does not.
As note, that way of constructing the path name looks a little odd to me.
What, this one? Which one?
Yeah, just that last one you have there. Having the file and extension in the directory list.
That works.
Yeah, I don't think that's standard. I think that's even less standard than having home in the directory list. But
Hold on. If you look in the hyperspec, all right, actually, and this is because of what I was saying earlier about Unix and Windows, all right? This works because this is one of the two forms that can be accepted. And it works in both ClojureCL, SBCL, ABCL. I mean, almost every CL that I've used, and the only one that I haven't really used is probably ECL and LispWorks. This works. It's actually a standard thing, and it's because of how it maps to the underlying file structure that it uses to call the operating system to check if it exists or not, the stat structure. I'm not saying that you should write it this way. In fact, I would say that this is probably, for most intended purposes, I'm almost always encourage folks to go ahead and split their stuff into this, which is name, test3, and type. Because this, from one standpoint, is kind of a form of documentation, right? Because you know what the file type is because you can just look at it. You know what the name of the file is because you can just see what the name is.
And it's not just that, though. I'd be interested in looking in taking apart. Actually, could you do something for me real fast?
Yeah, sure.
Take the first make path name invocation, right? Copy that to the REPL and wrap it in a call to the function swank::inspect in Emacs.
Well, I don't have the. I think once I construct it, I can actually just right click on it, right, and then it will show up.
Probably, yeah.
Give me just
That
one.
also should work.
Let me just make sure. Okay, so this guy, right click.
Yeah. All right. So just looking at that string representation there. You see the problem?
Yeah, it's a relative. The relative path.
No.
No, it's a directory.
No, it's a directory.
Yeah, it is a directory. It is a directory.
Directory.
That's a very. That's important.
After you probe, it figures out for you, I'm guessing, that it's actually a file, and it takes apart the path name and puts it back together again. But what you've just constructed there is not actually a file path. That was my point.
Okay. Gotcha. Yeah, that's that's good. So this is what I was saying earlier. Actually, if you
actually, could you do one other little thing for me? Call true name on that, if you don't mind.
True name.
True name. And then star.
Failed to find the true name. No such file or directory. So. Yeah,
that's sort of what I figured. So like if you try and pass that to open, it'll error out on you.
Actually, hold on. Let me try a real file then in this case, because that file I know doesn't exist. Let me see.
Okay. Fair enough.
Try this one.
Okay. Yeah, there it is.
So it went ahead and reparsed it and gave you, the actual file.
Yeah.
But by default, it treats it as a directory, which is wrong, actually. That's see, that confirms something that I saw earlier. So for folks, who haven't looked at this, so there are a bunch of nice things that you can do with paths. Just to go back to what I was saying earlier, you can actually, destruct the path and get access to it. It is an object, so you have some accessors to the different path functions like the directory, the name, the type of the path, and so forth. Again, as I mentioned, there are like 6 components of the path that are available that you can access. Even the version, although I don't think version is available because we don't use versioning file systems. But one of the nice things that you can do here is this guy right here that I want to show you. So you can actually merge different paths, one relative, one absolute, to becoming a single. Usually, the first argument to merge path names is a relative path, or it could be an absolute one, but it's usually a relative one. And then the second argument is an absolute path, and it will return an absolute path, or it'll return those two concatenated as second path name and first path name. An example of this that I wanted to show you is let's say that you're creating a website. This is straight from the book, and you can actually leverage this thing called enough name string to grab portions of your path once it's constructed. So just to show this guy to you, it will take the path that I created earlier, which is /www/html/foo/bar.html, and just give me the relative path that was there, html/foo/bar.html. So one thing here, and this is what I was going to get at, which I found interesting earlier today, is you can use this to actually go and replace parts of the path name and create new different path names like backup website, right? But one quirk that you'll probably not see is let's say that you forget the last slash there and you go ahead and rerun this. If you look at backup website, you'll end up seeing that it actually didn't actually merge it. And in fact, it did something worse. It just created an absolute path of /html/foo/bar.html. So the lesson here is if you're using merge path names in the lower thing, please put a slash or the appropriate backslash if you're using Windows at the end to merge the path names together. Otherwise, you're going to end up having things like this where it's not actually a directory, so it silently fails, and then it still calls the function. And then if you're not looking at the path that was actually returned, you're going to end up creating these random paths that just probably don't exist in a lot of cases, which could lead to pretty difficult to debug bugs that are available in your code. That's something that I learned earlier today, because usually I put it in, but I forgot it, and then I saw this little gem when I was running through the script. So
Common Lisp is the reason why I never again in my entire life shall type a directory name that does not have a slash at the end. Like no matter what language, no matter what I'm doing, my directory name always ends in a slash.
Same.
It was it bothered me for like 15 minutes. It was like, what is going on? And then I went through and actually debugged the make path name. I was like, okay, I see what it's trying to do. It's thinking that it's a path. I have to put the slash at the end. It doesn't treat it as such. So that's a really important lesson, folks. You need to put the slashes at the end if you're dealing with directories. Whether it's a backslash, if you're using Windows, or // it doesn't matter. Put the slash at the end of the freaking, In fact, I would say in Windows, Windows actually accept Unix style, path names, although they don't display it as such. If you do use a / in your Windows code, Lisp code, it will work. There are some other quirks that you might want to be aware of while writing on Windows, and usually it's I'm not going to get into some of those other quirks just because. Usually it's limited based on using Windows in general, but I will say that this, at least, lesson about putting slashes for directories, if you're writing portable code and you're on Windows, go ahead and put a / in it because it gets accepted by Windows no matter what.
So yeah, exactly. I was going to say, like, as one of two people that are doing Lisp and Windows, I would offer the suggestion of just always use // that's for Lisp, and like nowadays pretty much I mean, how even if you look at like Microsoft C# examples, a lot of times their paths will have a / in them. That's more or less the accepted canonical path name nowadays.
So this goes back to a lot of these convergences, as you can see, right? I mean, I knew that at some point it was going to get outdated, the path name API, and it did get outdated a lot quicker than what it should have. But they designed this at a time where they're like, well, damn it, how are we supposed to handle all these different combinations? So those of you who are just getting into the path name API, keep this in context, and know that there are third-party libraries that already handled a lot of the quirks for you. Maybe not all, but at least most of them that you would see on day-to-day basis. So you could just go ahead and leverage them like UIOp. So
also, if you're ever confused as to what the heck is going on with your path, inspect is your friend. Actually, just in general, if you're ever confused about what's going on with an object, inspect is your friend. But specifically with path name objects, because sometimes the thing you've gotten confused about is exactly where something's ended up in the components.
Yeah. And
that is why string path name designators and these path name literals that you're typing in are bad, because they're just like any other language.
Right.
You could always use make path name and type the components in that you need.
Yeah, I'll agree on that. I pretty much I generally don't use the #p literal, and I instead opt for constructing a path name. And typically the pattern that I use is UIOp, merge path names, make path name, and then specify the components that I want, and then give it the thing that I'm merging with.
I almost always end up using make path name just because I over time I just
Yeah, no, I'll use make path names, but I will always use UIOp merge. I think something that I've learned, and this is like more recent, if you're not using UIOp and you're dealing with paths, you are doing something wrong. There's some subtle bug in your code somewhere. I pretty much guarantee it.
Okay. I will
at the very least, UIOp merge. And as a Windows developer with device and host issues, that's especially true, because UIOp merge does device and host more reasonably than CL merge does.
Interesting. So you're saying that instead of using merge path names, saying you use UIOp merge path names,
yeah,
a different algorithm. Okay, gotcha.
Absolutely.
All right.
Sometime I'm going to have to ask you how UIOp handles what is it, UNC paths? Or if CL's path name system handles UNC paths on Windows?
Yeah, they it's been a while. I remember but they do. I can't remember like the specifics of it, but I think what SBCL does at least is it changes the
I would think that
host. I
host.
think, yeah. But I can't remember. Because I used to use them all the time at work. We had network drives like everywhere, and I remember writing build scripts and stuff that would move stuff to and from the UNCs, and ran into little trouble. So
Right. And that's one thing I would say, like with network drives, especially if you're not using host in some way, shape, or form, and you're just throwing everything into device, then the Lisp implementation, I think, is wrong, just because it's not doing, I mean, that I would expect, just because you're mapping a network drive, right? You're using a network drive, the host should be there, so I can at least go and inspect it in the REPL. I don't have to go and look at the device and parse it. It should be there already. But I've never touched UNC at all in Common Lisp, at least. I've usually used other languages when I handled network drives.
yeah.
So I'm gonna stop here for a moment and ask, Michael, Judd, you guys are online. You've been silent for a little while. Do you guys have any questions? Mike Gargano, Judd?
No, I had read this chapter like a couple of weeks ago, and then when I went ahead and read the practical chapter, I'd already forgotten like half the stuff. So it's just a lot to like take in, and there's a lot of little subtle things, and the function names are, it's hard to remember them because they're not like really tied to the object. They're just kind of like, I don't know. It's just a lot of stuff. But no, I don't have any questions.
All right. Yeah, I understand. This is a lot to take in. I mean, it's a very involved chapter. We haven't even touched the final piece about streams, and because honestly, streams, I would like to have a separate discussion on streams. He never talks about gray streams, but gray streams being available almost in almost all major Lisp implementations, it deserves at least some discussion in its own right on how to leverage it, because it's a really nice extension to the standard that just couldn't make the cut. It's like one of those extensions that's essentially standard, but nobody thinks about it as being standard because it's not part of the actual hyperspec. So I'm going to touch base on if you guys are okay with this, streams in a completely different discussion altogether, because I want to introduce, when we talk about streams, gray streams too as well. But the path name stuff in general is a very, very dense topic, folks. Again, it's going to be, to summarize, try to leverage UIOP when available. I mean, it is available for you now almost always, because it's part of your, especially if you install like Quick Lisp and you're using ASDIF behind the scenes, you're using it in some way, shape, or form anyway. So just go ahead and leverage it. Try not to.
Yeah, there aren't pretty much implementations worth their salt that don't bundle ASDIF, and if they bundle ASDIF, they have UEOP. So
if you have ASDIF, you already have UIOP. If you don't have ASDIF, you need to install ASDIF first anyway, because I don't recommend any other like def system or MK system and all those older standards. Just go ahead and use ASDIF as your system definition, and then that will install UIOP too as well behind the scenes.
Well, ASDIF is part of most implementations already anyway. It's part of SPCL, it's part of CCL. I don't know about the other ones, but
I think Elijah just mentioned that there are still some Lisps that don't have it. So if it doesn't,
I was more noting that the only ones that you should care about are the ones that already bundle it, because if they aren't bundling it, they're clearly well behind the times.
All right.
There may be implementations that don't bundle ASDIF.
one thing I will. Oh, go ahead.
No, I'm done.
I was just going to say that if you were to download ASDIF, make sure your implementation doesn't already have it, because upgrading ASDIF, it can wreak havoc on a lot of libraries and your implementation.
That's a very good point. Check if you have as if before you do anything else. That's like that's a very, very good point. I think though, in general, from this talk, if you got away with leverage the UI up where available, use path names almost always if you can. Path names are hard. I mean, then we've actually done something here. Today we've done something constructive because it will at least help you safely write your programs, at least to some extent, when you're dealing with files on in your common Lisp of choice. So I think we're at a point now that next week we'll start talking about we're going to actually continue our path name discussion because next week is we're actually doing a practical thing in chapter 15, which is creating essentially CLFAT. Because if I remember, CLFAT actually implements a lot of this API. So we're just going to re-implement this and discuss this a little bit to see how it kind of works. So that way you can get some practical experience also on the low-level API and really understand what we're talking about here today, which is how difficult path names really are in Common Lisp. So I just want to bring up one final reminder for folks. I'm going to just show my screen here about the Game Jam, which is on April 20th, which is exactly 1 month from now. Please go ahead and join the Jam. It's going to be a 10-day thing from April 20th to 30th. It'll take full 12 days. You can use any Lisp. You can use Common Lisp. You can use Scheme, Emacs Lisp, Clojure Lisp if you really want to. Yeah, have some fun. Try to learn how to write games. I'm trying to, as we get closer and closer, I'm going to try and bring up some game engines that I've been looking at to try and play with writing games in Common Lisp. I hope others that are in the channel would also step in and give their suggestions for newcomers trying to write games. So that way we can have a pleasurable experience when we're writing our games during the Game Jam. Are there questions, comments, any additional announcements from the general Lisp community that are here in today's Hangouts? Nope. All right, cool. Well, thank you so much for joining me, and I love the discussion. Thanks, Wilfredo. Thanks, Elijah. Thanks, Michael Fiano, for stepping in, and correcting some things and some interesting discussion on the path names. I hope to see all of you next week when we start talking about portable path names, and again, unless something really drastic happens, we're always on every Tuesday from 5:30 to 7. I will post a YouTube Live and Hangout Live usually about 45 minutes before the discussion. If not, I'll try to get it in earlier than that if possible. So thanks for joining. I'll see you guys next time.
Thank you.